Welcome back to Unit 9A, Day 3, Inscribed Angles. We've already defined inscribed angles as an angle whose vertex is on the edge of the circle, and we know that the measure of the inscribed angle is half that of the intercepted arc, or the arc is twice that of the angle. And then we talked about how if more than one inscribed angle intercepts the same arc, then all of those angles will equal each other. Okay, so let's see how we can apply algebra to that idea. I want to find the measure of angle U in this problem, and I want to find the measure of angle T in this problem. Okay, so when I'm trying to find the measure of angle U in this problem, here is angle U. I know that that intercepts the arc TW. So the angle that it's going to match with is going to be angle V, because both of those angles go to this arc. So angle U and angle V are both going to be half of that arc. That arc, let's see, if this is 30, this is 60, and this is 30. So angle U is 30 degrees. I didn't need algebra for that one. Just had to multiply by 2 and then divide by 2, or just know that these two had to be the same. Okay? The next one's asking me for the measure of angle T. For the measure of angle T, I can see that angle T is 3x plus 4. I know that its intercepted arc, if I come out, its intercepted arc is arc UV. So when I come back on these other two lines, angle T is going to match with angle W. So these two angles are going to equal each other. The measure of angle T is going to be equal to the measure of angle W. The measure of angle T is 3x plus 4. The measure of angle W is 2x plus 9. Okay, because angles that intercept the same arc are equal to each other. Okay, this is solvable using algebra. I'm going to move all my x's to the same side of the equals. Since they're on different sides of the equals, I need to do the opposite operations. I'm going to subtract 2x. And I end up with 1x plus 4 equals 0 plus 9, which is just 9. Now I need to move this 4 over to the other side of the equals, so I'm going to subtract it. X plus 0 is just x, and 9 minus 4 is 5. Okay, now it's not asking me for x, it's asking me for the measure of angle T. The measure of angle T is 3x plus 4. But now we know that x is 5. So the measure of angle T equals 15 plus 4. So the measure of angle T is 19 degrees. Now, it is nice to check your work. If I were to plug that 5 in here, would I also get 19 degrees? Because these two angles are supposed to be equal. 2 times 5 is 10, and 10 plus 9 is 19. So both angles are going to be 19 degrees. Okay? The next thing we're going to talk about is something called inscribed polygons. Okay? An inscribed polygon is a polygon whose sides are chords of the circle. That just means all of its vertices are touching the edge of the circle. Notice here all of my triangle points are touching the circle. Here all of my quadrilateral points are touching the circle. Okay? So an inscribed polygon is one whose sides are chords of a circle and whose vertices are points on the circle. Okay? Important things to know about inscribed triangles is if an inscribed triangle includes a diameter, then the angle across from the diameter is a right angle. So I'm going to write that down. if an inscribed triangle includes a diameter, then the angle across is 90 degrees. So when I look at this figure right here, I can see that I include a diameter, and I know that because I can see the center of the triangle. That means that angle A is going to be a right angle. Okay, so we need to always know that when we have an inscribed triangle that goes through the diameter. For an inscribed quadrilateral, and the reason that is, let's think about it, right? I have a diameter here, and then I have this inscribed triangle. So look at this angle. This angle goes to 180 degrees for its intercepted arc. The inscribed angle has to be half of that, right? Okay, let's look at an inscribed quadrilateral. If I were to take two angles of my inscribed quadrilateral, let's say I look at the left side here, which goes to this arc, right? And then if I look at the right side, that I'm going to mark in purple, hard to tell that's purple, it is, that goes to the other piece of the circle, it's not necessarily, there's not necessarily a diameter in here. If you look down here, you can really see there's not necessarily, if you look at the left side and the right side, there's not necessarily a diameter that's going to go that wouldn't hit my center of the circle, especially if I were to look at this top part and the bottom part, right? That wouldn't include the center of the circle. But I do know that this purple angle is half of this arc, and the pink angle is half of the rest of the arc, the rest of the circle. So if I take half of this part of the circle and half of the other part of the circle, then the two angles that are inside together are going to be half of the whole circle, 180 degrees, when I put them together. So this angle G and angle E, oops, which I should do in purple because I marked it in purple, are not necessarily going to equal each other, but they are going to be supplementary, because I know together what they intercept is the whole circle, and they're each half of that whole circle. So together they make 180 degrees. So I'm going to write down that rule just like I wrote down my right triangle rule. My inscribed quadrilateral, if a quadrilateral, or if a, yeah, we'll say if a quadrilateral is inscribed, so all four corners are touching the circle, then the opposite angles are supplementary. They're going to add up to 180. Now, if you see that word supplementary and you go, I don't remember what that word means, you definitely want to add adds to 180 next to that so you don't forget. Okay, so all that means is that when I look at this figure, I know that angle G plus angle E, the measure of angle G, plus the measure of angle E, is going to equal 180. And same thing here. The measure of angle D plus the measure of angle F is going to equal 180. And then all four angles together will add up to 360. Okay? Let's look at some examples. When I look at this first one here, I can see that I have a triangle, and I can see it goes through the vertex, so I know I have a right angle here. So when it wants me to find the measure of angle y, well, I've already done that. It is 90 degrees. Then it says to find the measure of angle x. Well, the measure of angle x is x, but I need to figure out what is that. Remember, we spend a lot of time on triangles for a reason. I know the three angles in a triangle have to add up to 180. So if I take my x plus 12, my x, and my 90, they have to add up to 180. So my x plus 12 plus my x plus my 90 have to all add up to 180. The three angles in a triangle add up to 180. So I have 2 x's plus 90 and 12 is 102 is going to equal 180. I'm going to subtract 102. And when I do that, I'm going to be left with 2x equals 180 minus 102 is 78. And then I'm going to divide by 2. And x is going to equal 39. So angle x is x, so angle x equals 39 degrees. The measure of angle w, now that I know that x is 39, I know that this is going to be 39 plus 12, so 51 degrees. And then you can check 39 plus 51 plus that 90 should make 180 degrees, and it does. Okay. The next one is the next two are asking me for measures of arcs. So when I'm looking at that one, I'm going to look at the measure of the arcs. The first one is arc x or arc WY. So WY is this one here. And I know that it goes back to angle x, which is 39 degrees. So I know this arc is going to be double that, right? So that intercepted arc is going to be double that inscribed angle, which is 78 degrees. Then it says, okay, what is the measure of arc XY? So the measure of arc XY here, if I go back, it's going to go to W. We know that angle was 51, so 51 was half of 102 degrees. Notice if I look at my pink arc and my green arc together, they're going to add up to 180 because look, it's one side of a diameter. So together they're going to make 180. Okay? Alright, in the next video we're going to pick up with the next example looking at inscribed quadrilaterals and the idea that my opposite angles are supplementary. Alright, so come on back for that next video.